A landfill has 50,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after m months? All right, they have defined our variable for us, telling us that m stands for the number of months. So if we think about this, we're starting with an amount of waste already in the landfill. There's already 50,000 tons of waste in that landfill. Each month, we're accumulating more waste, but notice it's each month. So in 1 month, there's 420 more tons, but in 2 months, there would be 840 more tons, or 2 times 420. So we need to add on the additional waste, but the additional waste changes with each month. 420 times the number of months would be how much is added over however many months we're talking about. And we're asked to write a function rule. So we can set this equal to y or f of x. We could choose t for total. It's really up to us what we want to have it equal on the other side. But it does have to be an equation if it's going to be a function rule. I could even say it's w of m. So the total amount of waste according to the number of months that has gone on. That would probably be ideal for this particular function rule. Looking at the next problem, a kennel charges $65 per day to board dogs. Anytime I see the word per, I know I'm probably going to end up multiplying something by this amount because it's a rate. Upon arrival, each dog must get a flea bath that costs $20. Write a function rule for n days of boarding, including the bath. All right, so we have n days of boarding, so they've told us that n equals the number of days. We know that we're charged $65 every day. So 65n represents how much we're charged to do the boarding. But while the dog is staying there, it has to have a flea bath so that it doesn't infect the other dogs. So there's additional cost of $20. This only happens once, so it's not multiplied by the number of days. It's just a one-time fee. Altogether, that gives us the total cost for boarding as a function of n, the number of days. So our function rule could be b of n equals 65n plus 20. But you might notice that there's more to this problem than that. We're then asked, how much does a 10-day stay cost? Well, that's a number of days. Since that's a number of days, that's something we could substitute for n. So b of 10, so the function evaluated for 10 days, would be 65 times 10 plus 20. Well, that's 650 plus 20, which is $670. So we can say that it would cost $670 for the dog to stay there for 10 days. Now, they ask another question asking us to apply this function rule in a little bit of a different way. Now they're saying, okay, your total bill is $280 for the pet stay. How many days must the dog have been there? Well, that's not something that we substitute for n because n is a number of days. This is something that we substitute for b of n, the total cost. So we would say that 280 replaces b of n, and we're going to have to solve for n. So now I've got to get n alone using my basic equation solving skills. I'm going to have to subtract 20 from each side. So I have 260 equals 65n. And then I need to divide both sides by 65. And I will see that n is to 4, since 260 divided by 65 is 4. So the dog must have been boarded for 4 days if the total bill was $280. A helicopter hovers 40 feet above the ground. Then the helicopter climbs at a rate of 21 feet per second. Although the actual word per is not written there, the unit says feet per second. So I'm starting to think that this is a rate. Typically when I have a rate, I'm going to be multiplying by something. This says write a function to represent the height of the helicopter. All right. The helicopter is already 40 feet above the ground. So that's definitely contributing to the current height of the helicopter. but then it's climbing at a rate of 21 feet per second. So every second that passes, the helicopter is 21 feet higher than it was before. That sounds like the height depends on the time. So if I let S equal the number of seconds, because they didn't give me a defined variable this time, I know that if I multiply 21 feet per second by the number of seconds, that should give me the height of the helicopter as a function of the amount of time the helicopter has been flying. In number 2, a new book is being planned. It will have a 24-page introduction. Each of the 12 chapters will include the same number of pages. We're asked to write a rule for the total number of pages T as a function in terms of the number of pages in each chapter. All right, so this 24-page introduction is separate from the chapters, so that's just 24 pages that go into this book. But then we know that there are 12 chapters, each including the same number of pages, and that the number of pages in the chapter is C. So if we multiply the number of chapters by the number of pages in each chapter, that's how many pages are contained within the chapters of the book. We're given a definition of a variable as T, so the total number of pages is equal to 24 plus 12C. This one we're not writing in scientific notation because they gave us a function, a variable, to represent the y value of the function. Our last problem is number 3.